Hello, everybody. Today we are going to talk about Hess's Law. I like to when teach Hess's Law, I like to think of it as a puzzle. So think of it the way you get to school. Is there more than one way you can get to school? Sure, you can take the long way or you can take the short way. But so you're going to start at the same place and you're going to end at the same place. So you can either take the shortest way or you could take a way that gets you all around, but you're still going to get there. It's just going to take you a lot longer. So that's kind of like how we're going to do Hess's Law. We're going to start off with some problems, and we're going to look to see that we still have the same end result. Okay, so the functions, it's path dependent. So depending on which blocks we can go on, or which highways we can go on, it'll all depend on which way we're going to go. So both lines accomplish the same result. They all went from start to finish. But if you have road construction on that red line, you're not going to be able to go on that way. So you're going to have to take a different way to get there. So now, here we have an equation. It says determine the heat of reaction for the following one. So we have 4 NH3 plus 5 O2s forms 4 NOs plus 6 H2Os. Okay, that's our goal equation. So now, I could use this equation, nitrogen plus oxygen forming NO, and it has a delta H of 180.6. That's one block I could go on. I could go on this block, N2 plus 3H2 forms 2NH3, and I'm going to have a delta H of negative 91.8 kilojoules. And I have this one, I have H's and O's and two waters, and that's a delta H of negative 483.7. So I have those choices of roads I could go on to get to where I need to go. This is where I need to go. So if I look at this one here, I like to start on the left. I need 4 NH3s. Which equation has an NH3 in it? The only one that has it is number 2. Right? So, but this still got 2 in it, correct? So I'm going to have to flip the equation. So I'm going to have NH3 on the left-hand side and the N2 and 3H2 on the other side. And I'm going to have to do what to that? I'm going to have to multiply it by 2. And if I flip the equation here, I need to flip the sign over here. So if I flip this, I need to flip that. So let's look at this equation. So we're going to reverse the second one and multiply it by 2. Everybody okay with that? So now I have 4NH3 forming 2N2 plus 6H2s. So now now I'm still not there. I have this, but I don't have these yet. So now let's look at oxygen. Go to the oxygen. Oh, I have 2 equations I could use oxygen in. Or no, I only have this one right here, right? And I need how many O2s? I need 5s, but I have other O's that I could be going there. So let's see. So we could add O's and O's. We don't know where to go. So just like, the other things we've done, if you don't have more in your balancing equation, always save oxygens till last. But because I have it in more than one place. NO. If I look at NO here, where do I have NO? The only equation that I have NO on is the second one. And it is on the correct side, right? It's on the right-hand side. So, but I need to do what to it? I only have 2 here, but I need 4. So I'm going to have to multiply them. Okay? So now I have 2N2 plus 2O2 forming 4NO. If I multiply it by 2, I have to multiply my delta H by 2. Okay, I still don't have any waters yet. And what am I going to have to do here? Am I on the right-hand side? The only one that's got water is this one here. The only one I have is here. So I have to do what to that? I have to multiply that one by 3, correct? And I can keep it on the same side. So now I have 6 H2s plus 3 O2s forms 6 H2Os. Now, just like before when we were doing spectator ions, you're going to cross off the things that can cancel out. So if I look at this, I have an N2 here, and I have an N2 there, right? They're both 2 N2s. Whoop. Oops. I cancel those 6 H2s, right? I can cancel my N2s, right? Because those, correct? They're the same, one on the right, one on the left. So now if I add this up, on the left-hand side, what do I have left? I have 4 NH3s. How many O2s do I now have? I have 5 O2s. Add this one plus this one together. Now what do I have on the right-hand side? This one's got rid of everything there, right? This one here, now my 4 NOs. And what else do I have? I have my 6 H2Os. So now I have to add up my delta H's. So I had my positive 183.6, the 361.2, and the negative 1,451.1. And my delta H for this equation would be a negative 906.3 kilojoules. Is that an exothermic or an endothermic reaction? It's a negative sign, so therefore it is an exothermic reaction. So once again, let's review what we did here. First of all, I took this equation here, and I had to multiply it by 2, and I had to reverse it. So if I reversed it and I multiplied it by 2, I had the 4 NH3s, the 2 N2s, plus the 6 H2s. If I reverse it, I need to reverse the sign. Oxygens, we skipped that one. NOs, we multiplied by 2, is still on the correct side. So I have 2 N2s plus 2 O2s, 4 NOs. H2Os, here, we had to multiply it by 3. Then we canceled out our like terms, and we added up everything on the left, added everything up on the right. And then we added up our delta H's. So once again, if I times it by 2, I had to times my delta H. If I times it by 3, I had to times it by my delta H by 3. If I reversed it, I had to change the sign, and then here I had to multiply it by 2. Okay? Next one here. So now this is my goal equation. I want to have C2H4 plus H2, forming C2H6. These are my pathways I can go. I can take the road that goes C2H4G plus 3O2, forming 2 CO2s plus 2 H2Os. In that one, I'm going to have a delta H of negative 1,401 kilojoules. My second pathway I could take is C2H6 plus 7 halves O2 plus 2 CO2s plus 3 H2Os. And that pathway is a delta H of a negative 1,550 kilojoules. And the last one, I have H2 plus 1 half O2, forming H2O. And that's got a delta H of a negative 286. So let's start at the top. C2H4. Whoop. We don't have a neighbor. Not doing this. Okay, so that's my goal equation. So what can I do here? I have C2H4. Which equation's got a C2H4 in it? Only the first one, right? Is the C2H4 on the correct side? Yes, it is. Do I have to do anything to it? Do I have to multiply it by anything? Nope, so I can keep that the same. Okay? Go to H2. Where do I see H2? I only see H2 in the third equation, right? I only see it in the third equation. So I can go keep that one as is also. And I keep my delta H the same. Last one is C2H6. Where do I see C2H6? Oh, the second one. Which side is it on? It's on the wrong side. So what do I have to do? That's right. I have to flip it. If I flip this, then I need to change my sign. So now if I change the sign, I now have a positive 1,550. And now I have 2 CO2s plus 3H2 plus C2H6 plus 7 halves O2. Now we need to cancel out like terms. So my 2 CO2s there. Ah, bam, I have another 2 CO2s there. What else do I have the same? I have 3 O2s, and I can get rid of 3 O2s right here, right? I can get rid of half there. And I get rid of some more over there. But I'm not good. But this is, so now my 2 waters. Okay. And what else do I have? Ooh, and my 3 waters, right? Because this is 2 plus 1 on the right-hand side. And I have 3 on this side. Here I have 3 halves, which is the same as 7 halves. So that's the reason this totally cancels out this one. These two added together cancels out this one. And this one cancels out that one. So what do I have left on the left-hand side? I have the C2H4. I have the H2. On the right-hand side, I just have my C2H6. When I add them all up, I get a negative 137 kilojoules. Endothermic or exothermic? That was an exothermic reaction. Okay. So the summary is that enthalpy is a state of function and is path independent. So on your assignment, you're going to have to calculate out, you're going to be given some different ones and some paths. You're going to have to calculate out the new delta H's. Okay. Good luck.